So let us begin with the next class on fundamentals of electrical engineering. So coming to next power generation, that is solar power generation. Here the working principle of solar power plant depends on the conversion of solar energy into electrical energy. We have two methods. One is direct method, other one is indirect method. So coming to direct method, see here, first actually solar energy, indirect method, first one is solar energy, and then that will be given to that solar photons that will be connected to PV panel. Next stage will be PV panel. So next will be DC supply that will be produced, DC supply produced. Next will be, that will be given to the battery. This system is called, this method is called direct method. So first solar energy, next stage PV panel, next is supply produced, that is DC supply. Next it will be given to the battery. So this is about direct method. So what do you say about indirect method? So indirect method is, so if we choose indirect method, then what is indirect method? So coming to indirect method, here there will be solar energy. That's, it converts more heat, it contains more heat. That solar energy will be produced. That solar energy, from there, the heat will be extracted, heat energy that will be given to that next stage is heat energy. Then that heat energy, next comes mechanical energy. That after mechanical energy, you can get the electrical energy. So this is indirect method, from solar energy, heat energy, then heat energy to mechanical energy to electrical energy. This is indirect method. So here, the advantage of the solar energy is it's freely available. No, it is freely available. It's abundant. No air pollution, no pollution. And then availability of fuel is unlimited. So no fuel storage is required. No fuel storage is required. And then no fuel transportation cost. Okay, no fuel transportation cost, no waste disposal, no need to start any power plant. Okay, these are the few advantages of solar power plant. Now we will see how exactly it works. So this is actually the solar power generation, this setup. Here we have so many components. You can see that's PV module, photovoltaic module, charge controller. From charge controller, it will be given to inverter, that is battery and charge controller connected together. And then the DC power is converted, is given to inverter, from inverter to utility power or loads. Okay. Now, what does this PV panel does? Its main function is to convert energy of sunlight directly into DC electricity. So what battery charge controller do? Its function is to increase the life of the storage battery, and it prevents battery from overcharging, and it prevents battery from overcharging and as well as from over discharging. That is actually it prevents battery from overcharging. Next, storage battery. That storage battery, its function is to store DC electrical energy generated by PV cell, which can be used whenever it's required. So this battery has long life. Example, lead acid battery or nickel cadmium battery. You can quote the examples. And coming to inverter, this inverter converts DC supply into AC supply. So why transformer is required? Transformer to step up the input voltage to utilization voltage. You can see here. Utilization voltage is 230 volts. And then how exactly the voltage, the generation of electricity is done? The generation of electricity is on exposure to sunlight is known as photovoltaic effect. Okay, you are generating the electricity. So the generation of electricity on exposure to sunlight is known as photovoltaic effect. Now the solar cells are made up of semiconductors, mainly silicon, and comprises of 3 layers. Top layer is called N-type layer, which is comparatively thin and contains high concentration of electrons. And the bottommost layer contains high concentration of holes. When P-type and N-type joins, it actually makes a PN junction. So on forming the PN junction, the electrons of N-type material try to reach the P region, creating a negatively charged layer. So similarly, the holes of P-type material try to reach the N region, creating a positively charged layer. This region between the 2 layers is known as depletion region. So sunlight actually penetrates the topmost layer easily to reach the depletion region. So due to the deficiency of charge in depletion region, it contains neutral atoms. So these neutral atoms are broken when the photons from the sunlight strike the depletion region. This knocks the electrons from the neutral atom, leaving behind the holes, so that producing free charge carriers. So then these electrons move towards the N-type layer and the holes move towards the P-type layer due to the electric field present in the depletion region. So on connecting an electric circuit, the electrons flows through this. So the setup that is solar PV panel you are seeing here, this is how actually exactly basically the PV panel works. So next, moving on to the next one, that is wind power plant. The wind power plant, you can see here the wind power generation. How wind energy is converted into electrical energy. So the generator converts mechanical energy into electrical energy. That is, rotation is getting converted into voltage and current. So we require mechanical energy. See, because of curvature shape of Earth, there is uneven heating of Earth's surface. So there is uneven atmospheric pressure also. And there is always tendency of air to flow from high pressure level to low pressure level. So there is continuous flow of air. So air in motion is called as wind. So when the pressure of air increases, it is called as wind. Wind actually possesses high kinetic energy. If this kinetic energy of wind is used, then kinetic energy is used as mechanical energy. Then this mechanical energy can be converted into electrical energy. This is the basic of wind power plant. So then how to convert this kinetic energy to mechanical energy? That is the thing we have to know. Firstly, we'll have tower. On the top of the tower, we have blades or propeller. Okay, we have blade. You can see here blades of propeller. The tower gives the mechanical support. The function of the blade is to capture the wind energy. So when wind blows or flows, the blade, it captures the kinetic energy of that wind and converts the kinetic energy into mechanical energy. But when the blade rotates, it has a low RPM. So this low RPM is not enough to generate electricity, and that's why there is a need of drivetrain or gearbox. Okay. So gearbox is used for the same purpose. So this gearbox converts low RPM into high RPM. This then this high RPM is given to generate where mechanical energy is getting converted into electrical energy. Then generated electrical energy is given to grid. This is the function of wind power plant. Sometimes it may happen that due to high pressure of wind, the mechanical structure of blades can be disturbed and generators may also be disturbed. So the controllers are used. The generators gives the signal to the controllers and controller controls the speed of the blade. That you can see here. In the diagram, you can see the complete power plant, wind power plant. What are the different components involved in wind power generation and how they are placed and the working of it. So thanks for watching. For more videos, please subscribe to our channel. And for any queries, you can write to us. That completes today's topic. Thank you.